So let's go ahead and look at our warm up here. So square root of 1 is what? Is 1. Square root of 4 is what?
2.
Square root of 9?
3.
Square root of 16? Square root of 25? Okay, so you get the idea.
Have you noticed they go up?
All right. Now, what does it mean to do a square root? What are you doing?
No, not that.
Okay, and okay, so let me talk about what he said first. So that's what a lot of people think. They think it's just half. No, it's not half.
Oh, it's how many times that number can go into it.
Okay? Kind of. Okay, so when you're doing a square root, what you're doing is you're looking for some number times itself to give you that number underneath the square root, or we call it a radical. Okay? So with this one right here, with square root of 25, I'm looking for some number times itself that gives me 25. So what number times itself is 25? It's 5. Okay? Because 5 times 5 gives us 25. Okay? So you got that down here at the bottom. Square root of 169 is what?
13.
Square root of 196 is 14, because 14 times 14 is 196. Square root of 225 is what?
15.
And then square root of 625 is 25. Okay, all of these numbers on this side are what we call perfect squares. Okay? All of these numbers are what we call perfect squares. And the reason they're called perfect squares is what's happening here. If you take the square root of these numbers, it gives you a whole number answer. Square root of 49 is just even 7. Square root of 121 is just an even 11. Okay? So all of these numbers are perfect squares. Now, on the other side, we're going to talk about numbers that are not perfect squares. So obviously we're starting into a new unit today. We got done with our similarity and proportion stuff. And we're starting in here. We're going to spend a few days on the simplifying radicals because it ties into what we're doing. But this unit we're about to be doing is going to last for a long time. In fact, we'll be doing it even after we get back from Christmas. So it'll be split up into a few tests, but it's just one huge long unit that we're about to be doing. Okay, so I want to simplify these. So real quick, in your calculator, type in square root of 20. Tell me what that is.
4.47214.
4.47214. Is that what it is? Okay. What we're going to be doing today is we're going to be simplifying these radicals, these square roots. And when I say simplify, I do not mean do this. Do not give me the decimal. That's not what simplifying means. I just wanted to write it down this one time so you can see this is not what I'm talking about when I mean simplify. Okay, so simplifying is like this. All right. If I gave you the fraction 4 over 8, what is that simplified? Is 2/4, or you could even take that one more step to 1/2, right? 4 over 8 simplified is 1/2. Now, 4 over 8, is that equal to 1 over 2? Are these two numbers equal to each other?
No.
Yes, they are. Okay, 4 over 8 is equal to 1/2, 0.5. 1 divided by 2 is equal to 0.5. So these two are equal to each other, but they look different. Okay? And that's what's going to happen here. We're going to simplify square root of 20, and the answer is going to look different, but it's still going to be the same number. All right, so here's what we're going to do. We're going to start off with this 20. And what we're going to do is we're going to do a factor tree on this. This may take you back several years. So what I want is I want two numbers multiplied together that give me 20. 1 and 20, that's not going to help me out much. What else? 2 and 10, and 5 and 4. Okay, it does not matter where we start. We're going to end up at the same place. Okay? So I'm going to go ahead and start off with 4 times 5. If we did 2 times 10 there, we would get to the exact same numbers. So it does not matter how you start here. Okay, 4 times 5 is 20. Now, I got to think, can I break down either one of those two numbers?
No.
4 breaks down as what? 2 times 2. Can I break down that 5?
No.
No, the only way I could break down the 5 is 1 times 5. That means it's already broken down as far as it goes. That means it's already prime. All right, so that's what we're doing, is breaking these down to their prime numbers. Okay? Now, can I break down any of those numbers at the bottom?
No.
Nope, I can't break down a 2. I can't break down a 5. So what I'm going to do now is I'm going to go back over here, and I'm going to put those 3 numbers underneath this square root symbol or this radical. Okay? So I'm just taking those three and I'm putting them back over here. Bless you. So what I'm going to do now is I'm going to look for pairs. Are there any pairs up here?
2.
Yeah, there's a pair of 2s. Okay? So that's what I'm going to do is I'm going to go look for the pairs and circle all the pairs. In this case, there's only one pair. Sometimes there may be more than maybe 3, 4, or 5 pairs. Here there's one pair. Okay, now think about this. 2 times 2, okay? 2 times 2 is what? Is 4. And if I take the square root of 4, what does that give me? Okay, it gives me 2. Okay? So after I do that, the square root of 4 is 2. That goes outside of the square root symbol. Did this 5 have a pair?
No.
Nope. So it stays underneath. And so we end up with this. 2 on the outside and 5 on the inside. So if I were to simplify square root of 20, this is it simplified. 2 square root of 5. Okay. In your calculator, type in square root of 20 real quick if you haven't already. Type in square root of 20 and push enter and see what it gives you.
4.47214.
Okay? Now type in 2 times the square root of 5 and see what that gives you.
4.47214.
Okay, do these two things give you the exact same number? Yes. Okay? So that's what I'm saying. They're the same thing, it's just that this is the simplified version of that. Okay, number 2, square root of 18. So how does 18 break down? 2 times 9 is one way. What's another way? How else could you break down 18? 3 times 6. Okay? So again, we could put 2 times 9 here. We could put 3 times 6. We're going to end up at the same place. Okay, I cannot break down a 2, so I'm just bringing that straight down. How does a 9 break down?
3 times 3.
Breaks down as 3 times 3. Can I do anything to any of those numbers at the bottom there? Nope. So I'm going to take those, write them underneath here. 2 times 3 times 3. Looking for pairs. Are there any pairs there?
Yes.
Pair of 3s. Okay, what is 3 times 3?
9.
It's 9, right? And if I take the square root of 9, what does that give me? 3. So I've got a 3 on the outside, a 2 on the inside, and that's it. So square root of 18 simplified is 3 square roots of 2. All right? Number 3. Okay, we just did this on our warm-up. What is the square root of 16? Is 4. We already know that, okay? We already know that. The square root of 16 is 4, but I want you to see this. So how can we break down 16? 2 and 8 would work. Okay? So the 2 can't break down. How does 8 break down? 4 times 2. Can I break any of those down? This 4 can break down again. All right. So what I'm going to do is write this last row underneath here. 2 times 2 times 2 times 2. Right? There's 4 2s. Are there any pairs up here?
Yes.
Yeah, there's 2 pairs. There's a pair here. There's a pair here. So with these, there's a 2 going to come out. With these 2, there's going to be another 2 that comes out. Now, when you bring stuff out, you multiply everything that you bring out. So there's a 2 and a 2 we brought out. We multiply those 2 together, and what does that give you?
4.
Gives you 4. All right? Same thing there. Okay, number 4. How does 52 break down? What 2 numbers multiply to give you 52? Yep, good. 26 and 2. There you go. All right, nothing, I can't do anything to that 2, so I'm just going to bring it down. How does 26 break down? Yep, 2 times 13. All righty. I can't break down the 2, that's already prime. Can I break down 13? Nope. Okay, so I'm just going to take that, put it underneath the radical here. 2 times 2 times 13. Looking for pairs. I have one pair of 2s. 2 times 2 is 4, and the square root of 4 is just 2. And then the 13 didn't have a pair, so it just stays underneath. We get 2 square roots of 13. All right, number 5. Okay, try that one. Square root of 27. Okay, what can you multiply to get 27? 9 times 3. And then 9 breaks down as 3 and 3. And then still with this other 3. All right, so we have 3 times 3 times 3. Okay, again, let me just say this. So if you just do 3 times 3 times 3, what does that give you? Gives you 27, okay? So this number underneath here is still equal to this. It's just that we've broken it down, okay? 3 times 3 times 3 is 27. If you had something where you multiplied these and it gave you something different, then you messed up on your factor tree. Okay, so are there any pairs in there?
Yes.
Yep, pair of 3s. 3 times 3 is 9, and the square root of 9 is just 3. So you get 3 square roots of 3. Okay. All right, number 6. 400. Okay. 100 times 4. 100 could break down as 10 times 10, right? And 4 is going to break down as 2 and 2. Then 10 is going to break down as 2 and 5. Another 10 is 2 and 5. And then we still have this 2 and this 2. Okay. So, that last row, I'm putting all of those in here. Okay, now when it's like this, where they're all, in different orders, I'm just going to list them in order from least to greatest. So how many 2s are in there? There's 4 of them. So I'm going to put 2, 2, 2, and 2. Then how many 5s? 2 5s. So there's a pair, there's another pair, there's another pair. So notice everything paired up here. So whenever I get done with this, there's not going to be the square root symbol left anymore. If everything goes out from underneath there, there's no reason to leave it. Okay? So, with this set of 2s, there's going to be a 2 that comes out. With these set of 2s, there's going to be a 2 that comes out. And with these set of 5s, 5 times 5 is 25, and the square root of 25 is just 5. So everything's out from underneath there, so that part's going away. And then on the outside, 2 times 2 times 5 is what? Is 20. 2 times 2 times 5 is 20. Which, in this case, you can see that that number 400 is actually a perfect square. If you just typed in square root of 400, you would see it just gives you the whole number of 20. Okay, next one, number 7. Let's break down 14. How does 14 break down? 2 times 7. Can I break down 2 or 7? No. Are there any pairs right there? No, there's no pairs. Okay, so what that means whenever there's no pairs is it means that it is already simplified. It's like this. If I gave you a fraction 1/3 and I asked you to simplify 1/3, could you simplify 1/3? No, that's already down as far as it'll go, and that's the same thing that's going on here. So that's the answer. Square root of 14 is as simple as that gets. You can't break it down any further. Okay, I'm going to skip number 8. Let's look at number 9. Now, on number 9, there's already a 5 on the outside. So 5 square roots of 45. And what we're going to do is we're going to break down the 45 like we've been doing, and then we'll get to that 5 in just a second. So how does 45 break down?
5 times 9.
5 times 9, which the 5, I can't do anything else to that, and then 9 breaks down as 3 times 3. Okay, so here's what I'm going to do. Just bring that 5 straight down. We'll deal with it in a second. Then underneath here, I've got my 3, 3, and 5. Are there any pairs there? Yes. So that brings a 3 on the outside here. Okay, now, if there's happens to be something already on the outside, that's fine. We're just going to multiply whatever we bring out times that number. So on the outside, we brought a 3 out. There was already a 5 there. So when we multiply those, what do we get? 15. On the inside, that 5 didn't have a pair. It stays underneath. We get 15 square roots of 5. And again, if you want to check, you could type in 5 square root of 45 in your calculator and type in 15 square root of 5 and see if that gives you the same thing. And those will. Okay, number 10. All right, how does 125 break down? 5 times 25. Okay, can't do anything to that 5. The 25 is 5 and 5. So I've got a 4 on the outside. Nothing changed that yet. Then on the inside, we have that 5, 5, and 5. All right, so I've got one pair. Five times 5 is 25, and the square root of 25 is going to bring a 5 out. So we have a 20 on the outside and a 5 on the inside. Okay, so number 11, there's a few ways you could do it, but the easiest way, well, maybe not the easiest, but one way to do it is just to go ahead and multiply them across. So 3 times 9 is 27, and actually I already worked that one out on number 5, so I'm not going to work it out again. Square root of 27 simplified is just 3 square root of 3. Okay, on number 12, what's 5 times 30? It's 150. Okay, so let's break down 150, which obviously it can break down as 5 times 30. So we get 5, 3, and 10. We have 5, 3, 2, and 5. Okay, so we have 2, 3, 5, 5. Just rearranging those from least to greatest. So I've got one pair here. So what am I going to bring out? There's going to be a 5 on the outside. Now if you have it like this, if there's anything left on the inside, it's just like on the outside. Everything that's left just gets multiplied back together. So that's going to make 5 square root of 6. Okay? All right, one more. Number 13. What does it mean to square something? Multiply it by itself, exactly. So if you have square root of 11 times square root of 11, that's what that means. Square root of 11 squared means square root of 11 times square root of 11, which is square root of 121, which we just did that a second ago in our warm-up. What's square root of 121? Is 11. Okay? If you think about this, what's going on here is you have a square root and a square. Okay? You have this square root and this square. These are inverse operations. Okay? Like add, subtract, multiply, divide. They basically are exact opposites. So what happens in this cases, it just cancels out that square root. The square and square root cancel each other out. So on this one, if you do square root of 8 squared, what do you get? You just get 8.